In this question, we need to rewrite the function in vertex form by completing the square of f of x is equal to x squared plus 6x plus 5. We'll do so by using algebra tiles, by using the algebraic method, and finally by verifying graphically. So let's start with the algebra tiles. Notice that we'll need one x squared tile and 6 x tiles. Let's start there. Next, we'll drag on our 5 ones tiles. If we take a look now at the region that needs to be completed, this square, we can see that we have a 3 by 3 region. So we'll fill that with 9 ones tiles. Now, we can't just arbitrarily add in 9 ones tiles. If we want to do that, we need to add in the same amount of negative ones tiles on the outside of our square. Finally, we know that a 1 and a negative 1 tile makes a 0 pair, so we can remove those tiles to see what we're left with now that we have completed our square. As you can see, we've completed our square. We have a side length of x plus 3 and x plus 3, or x plus 3 all squared, and 4 negative 1 tiles left on the outside. Next, let's take a look at using the algebraic method. We'll start with our equation first. Y is equal to x squared plus 6x plus 5. The next thing we need to take a look at is our leading coefficient. Is there anything that needs to be factored out? In this case, there isn't. The only thing that we factored out technically would be a 1. So we'll factor a 1 from the first two terms, giving us the following. Next, if we take a look at our middle term, or our b term, 6, we divide it in half, which would be 3. 3 squared would give us plus 9, minus 9. So that step's already in the right spot. Now from here, the negative 9 needs to be multiplied by our leading coefficient, which is a 1, to move it outside of the brackets. So we would have this step coming next, such that the negative 9 has been multiplied by 1 and pulled outside. Notice that we can gather our like terms. Negative 9 plus 5 is negative 4. And then finally, if we complete the square, we have x squared plus 6x plus 9 is equivalent to saying x plus 3 all squared, no different than what we had with our algebra tiles. Finally, now that we have completed the square two different ways, let's verify algebraically. Notice that our a value would be 1, our p value would be negative 3, and our q value would be negative 4. And as you can see, our graph matches, so we are correct. Finally, let's check our solutions.